Hi and welcome back to my channel. My name is Joshua from Tag. In today's video, we'll learn more on how to assess elements of a matrix, but this time around we'll learn how to use logical vectors. So let's start by creating a matrix, still using the name met. So we're going to use matrix from the base package, and the data I'm going to use will just be 4 7 1 3 5 8, and yeah, it's okay, 6 of them, and then the dimension will be a square matrix 3 by 3. So you can print the matrix using the print function, and then you say met and you run it. So let's have a recap to what we did in the previous video, how you could access using an integer vector. So I could easily say met and use square bracket and say C1, 2. That's for the condition for the row, and then specify the condition for the column. I could say 2 and 3. So if I run this, this is what the result will bring out for us. So now this concept we are learning using the logical vector, it's also an important concept, and let's see how we can use that to arrive at the result of the code we have in line 4. So this is what we are to do: square bracket, and then I will use this, and here using logical vectors you are just going to be putting true or false. So look at what we have. The condition for the row, we are interested in row 1, so if row 1 is included, we put true. Row 2 is included, so row 3 is not included, we put false. So we go to the column condition. Row 1 is not included, it is going to be false. Row 2 is included, and row 3. So if I run this, it's going to give us the same result we have in line 4. So now one very important concept here is the concept of recycling. But before we go to that concept of recycling, let's just treat one more example and say met, and say this, and you say false, true, and let's say false. That's the condition for the row, and you have this to be true, true, and false. So if you run this, this is the result we are going to have, 7 and 5. So if you are to write this code now using an integer vector, indexing this matrix using an integer vector, the code is going to go like this. So see, so we don't even need to combine it, because it's just one of it that is true. And which one of it is true? Row 2. And then we'll go to the condition for the column. 2 of it is true, and that is column 1 and column 2. So if you run this, you're going to have the same result. So this is just an easy thing to do using arrow. So the concept we're going to learn next is the concept of recycling. And so what do I mean by recycling? It's just very simple. I'm not going to speak much grammar. So it's going to be true if this is true and false. Recycling tells us that the next will be true, the next will be false, true, false, like that. This is the way arrow works. So let's have like an example using this concept of recycling, and see how I will print out the result for. So if I have, for instance, I have true and false as the condition for the row, and the next I have false and true. This time around I am not specifying like 3 logical statements as we have in line 8. I just use 2 of it. But let's see what the result will bring out. I have 3 and 8. So what is the implication of this 3 and 8? Now, what is happening in 14 is what we are going to rewrite again in 16 using the complete logical operators like in 3. So if I say met, and I have this C, so this is true and false. So if what has happened, the way it printed out this 3 and 8 is that arrow does what we call recycling. So here automatically it recycles it and puts true, true, false, true, and then go to the condition for the row. This is for the column, I mean. So false, true, the next will be false. So if you run this, we have 3 and 8. So if you are to write it using the integer vector, it will be met Very simple. 2 of it are true, so that's row 1 and row 3. The condition for the column, only one of it is true, so I don't need to combine it, so I'll just put column 2. So if I run this is how we arrive at TV and 8. So this is something very important, because to every of our code it is also good to understand the outcome. So the next thing we're going to learn is how to stack the entire column together and get to index the matrix without imputing the condition for row and column. So for instance, if I say met and I say met true and false, if I run this, look at, we have 4 1 5 4 1. What is happening here is that Harry is also using that concept of recycling to print out this result for us. So let me explain this result. Let me print met so it will make much sense, so we can view it. And then let's run the whole thing again. Met square bracket C, and we have just true and false. So if I run this now, what is going on here is that, okay, it starts from 4 and it counts down column after column to this to this. So what is going on here is that 4 is true, automatically 7 is false. So it starts recycling after that false, and it tells us that 1 is true. So that's why we have 1. 3 is false, is excluded. 5 is true, 5. 8 is false, excluded. 4 is true, 7 is false, and 1 is included. So this is the way it prints out that result. So let's confirm it by changing the order. So if you have this and we have false and we have true, so if I run this, let's go back. Okay, let me run met again and run this. So now what's going on is that 4 is false, so 7 is true. That's why we have 7. So recycling starts after this true, and it tells us that 1 is false, so 3 is true. 5 is false, 8 is included, is true. 4 is false, 7 is true, 1 is false. So this is how we have a result as that. So using this same concept, you can apply it by just saying you can apply without specifying any condition for row and column. You could say this greater than 5, and it prints out all the elements in that particular matrix that is greater than 5. So you could say greater than or equal to 5, and if you run this, the 5 that we have in the matrix is included. At the same time, I might be interested in printing out the odd values, odd numbers in this particular matrix. So I could say this, and then here we now use the concept of the modular division we learned when we were talking about data operators in R. So if I do it in this particular dimension, so I will use the modular division. So if I divide anything by 2, if it gives me 1, I know this is an odd number. So if I run this, I'm going to have the odd values that we have in that matrix. So if I'm going to get the even values, the even numbers, automatically, you know what I'm going to do is I'm still going to use the modular division, divide it by 2, but it won't have a remainder. If you divide an even number by 2, there is no remainder, so I put 0. So if I run this, I just have the even numbers that are present in that matrix called met. So this is one very nice thing we need to understand when indexing a matrix using logical vector. So thank you very much for your time. I hope to see you in the next video. If you are new to this channel, you can subscribe and turn on the notification bell to be the first to view my next video. Thank you very much for choosing to learn R with me. Do have a great day. Bye bye.